Hello, everyone. This is Pittsburgh Java User Group. I'm Sirisha Prata, and I've got Renat over here who is busy admitting people. So if you want to learn more about Pittsburgh Java User Group, you will find our information on the Java Meetup page, which is where you'll find about our upcoming events. And that is where you will be registering as well, which you already know because that's what you did to get here today. And if you have a Twitter account, please do follow us at PG@Java Meetup. We do like to share resources from other Java user groups and also other just Java news that we come across. As you all know, all of our sessions are recorded and you will find them at the Pittsburgh Jog channel. Please subscribe to it so you will be notified as soon as we edit and upload a new video, which is typically usually like 4 days after the session is over. So that's about how long it takes for us to edit and upload it. And we have a winner from our April session, the Amazon Echo winner. It's Sean Mack. I see that he's registered for the session, so I'm just assuming that he'll be joining in a few minutes, but I will remind this again. I'll put this in the chat later on again. And for our upcoming sessions, we have Anna Maria, who will be presenting to us on June 30th. We have DevOps UK happening at a couple of other conferences happening during the middle of June. So this is like the earliest date that we could find with our speakers. And we would like to thank our official sponsor, JFrog. In fact, they are the ones who will be providing the Amazon Echo speaker as well. So I will work with Sean and JFrog to get that going. With that, I do want to hand it off to Don Raab. Don, if you could introduce yourself and take it away. I will stop sharing though first. You're on mute.
Don
Today
knows.
is the day of
Just trying to give focus to the screen. It zoomed off, so I'm like, where's the Zoom screen so I can click the mute? All right, so thank you, Sirisha. I'll start sharing. A second. Can you see my screen?
Yes, we can.
Yeah, yep.
Okay. Look at going here. So going to jump right in. So today I'm going to give a talk about Smalltalk or Java and really hopefully get folks who watch this either live or via recording to be interested in actually learning the Smalltalk language and understanding how it can help you become a better either Java programmer or Python programmer or JavaScript programmer, pretty much help you become a better programmer in any language. So with that, just a quick blurb about me. So I'm a developer, blogger, author, creator. I maintain an open source collections framework along with my fellow committers like Sirisha. It's named Eclipse Collections. You can find me on Twitter at the Don Raab. I blog at least once a month, sometimes more, on donraab.medium.com. And you can find me in GitHub at Don Raab. So that's that. So a little bit of, I guess, like as we jump in, I'm going to be doing some diving into code. I like coding more than I do like preparing slides. So, but I wanted to at least give a little bit of context. I've been programming since I was 11 years old, and pretty much like these aren't all of the languages I've learned over the years, but I would say the major ones and probably interesting ones. And I started off with BASIC in the early 1980s. Went through a bunch of languages through the 80s and then into the 90s when I had graduated college and started working. Really, I would say the three primary languages that kind of impacted me in the 90s and then leading into the last 20 some odd years. Started out with Clipper 5.x. I'm going to go into a little bit something that's now shared in common between these languages. So Clipper 5, I'd been programming in Clipper Summer 87 since around 1989. Picked up Clipper 5 in around 1992. Then I learned Smalltalk at the end of 1994 and actually learned Visual Age for Smalltalk. And then I had started out learning Java. I didn't program professionally in Java until like around 2000, 2001, but I started learning it via Visual Age for Java around 1997. One of the things that looking across the three languages, and really now this is spanning 3 decades of professional development. Each of these languages has support for lambdas, right? So when I first learned lambdas, it was in Clipper 5.x, and I didn't actually know they were called lambdas back then. We just referred to them as code blocks. And I had a syntax like this where you had curly braces surrounding the whole construct, and then pipes surrounding the parameters, and then to the right of the pipe some expression. A few years later, when I learned Smalltalk also referred to these as blocks. And depending on the Smalltalk that you work in, it could be a class that implements a called block closure or block context template. This was the syntax where it's like square brackets, and Smalltalk developers often use the syntax for blocks as a kind of ASCII logo, where I can say, like, I'm a Smalltalk developer. Here's, they call it, I guess there's a term they use called the Knights of the Square Bracket, right? So you've got the square brackets and then the pipe separator for the parameters on the left and the expression on the right. Now, years, I guess, later, Java 8 happened in 2014. And, I think Java probably one of the maybe last programming languages on the planet that finally got Lambda support, right? So, and the Lambda support, if you've got multiple parameters, it'll be a syntax like this, where you'll have parentheses around your parameters, the dash greater than separator, and then the expression and or statements on the right. So 3 decades, 3 different languages, all this common thread of lambdas, right? And hard for me to imagine ever programming in a language again without lambdas. So I think I can, unless once again I'm paid obscene amount of money, I'm not going to be looking for any languages that don't have support for lambdas. So a little bit of, I guess, stuff as we're going, through the code and whatnot. I've got some blog references that you might find useful. So really, once again, I'm going to be comparing and contrasting, Smalltalk and Java. In the Java space, I'll be focusing on Java with the Eclipse Collections library, and I'll explain in a slide why that's the case. But some blogs that kind of focus on, Smalltalk, some that focus on Java, and there's a ton of other blogs at my Medium account, which really focuses mostly on Java and Eclipse Collections. There's one blog on Python, I think one on Kotlin, but for the most part, Java and Eclipse Collections. But then there's like a couple of blogs that actually kind of bridge the span between Smalltalk and Java. One was this: Java streams are great, but it's time for better Java collections. Wrote this in like February of 2020. And really, it was kind of like a proposal that, now that Java has lambdas, has streams, they're great, but like it would be much better if we actually had a better, collections framework. One could argue that we already do. It's called Eclipse Collections, but it would be nice to once again have more features in the Java collections framework itself. So that said, so looking at, Smalltalk and Java, like what kind of influence and impact have they had? Well, really, Eclipse Collections, if you've heard of the library, and if you haven't, I would say like Eclipse Collections was largely inspired from my experience as a Smalltalk developer. And, it's been in development now for 18 years. It's been at the Eclipse Foundation for 6. It's been in open source for a little over 10. It started off its life in open source as GS Collections in 2012. Was migrated to the Eclipse Foundation at the end of 2015. What you can see here in this table, though, is like the things from Smalltalk that influenced Eclipse Collections, and then the things from Java. And you can see it's kind of like got this, best of both worlds in terms of the features that you find. In some ways, maybe it has the worst of both worlds too, right? It's like we had to kind of embrace with grit the ugly realities of Java, where you have a type system that includes both objects and primitives. And we looked at that as kind of like a divide that we wanted to bridge by providing things like primitive collections, right? Smalltalk is a dynamically typed, pure object-oriented language, so it doesn't have primitives. Well, not in the sense like primitive types like Java does, but it also like I would say Smalltalk is a fairly mutable language. There are some features built into it. They added, not too long ago where you can set, let's say, objects as read only, but really, that flag can be turned on or off. And I think pretty much like you can pretty much like mutate anything you want in a Smalltalk. It's a reflective language. You can just have at anything. So it gives you an immense amount of power, and then it, gives you also an immense amount of responsibility as a developer. But once again, like I guess looking back, it was really from Smalltalk and then previously in Clipper, like the impact of blocks and lambdas, learning about internal iterators. There were different types that you don't find in the JDK today, like bag and interval. Things like, string as a collection. In Java, we think of like, string has it used to have an array of char. I think now if you look in the latest implementations, it's an array of byte. Right, and they've done some optimizations for memory there, which is great. But conceptually, from an API perspective, like really string, and this is the way it's represented in Smalltalk, is a collection, right? It's a collection of characters. But you can see other things on the right over here from Java. Java has great concurrency features. Had the ability to leverage threads. So, and this is where things like a parallel API, concurrent data structures, immutable collections. So Java has, really, I would say, pushed a lot, which is great. The idea that, hey, we should be using more, immutable types, right? So that we can better reason about our software and not worry about things changing out from under us. And that's extremely important when you're dealing, with either concurrent structures or, parallel APIs, right? Where you have maybe multiple threads competing for stuff. So that said, so you can see once again, this both worlds kind of coming together in Eclipse Collections, right? And what I think most folks don't ever see though is like you might hear me talk about the influence and inspiration of Smalltalk, but most developers have no idea what the heck I'm even talking about, right? So I thought today, like, hey, let me power up my Smalltalk ID and actually show you what's going on underneath the covers, and really then do some comparing and contrasting between Smalltalk and Java and what the capabilities are. And what you'll also see is how Eclipse Collections, and I would say the primary reason I created it was like I was missing the feature richness of a Smalltalk that I had in the 90s, and I wanted to have that same feature richness in Java. No one else was providing it to me, so I, just started building it on my own. And 18 years later, we have this huge framework that's available in open source for all to use. So with that, I'm going to switch to get out of the presentation mode. I'm going to switch to my ID. So what I've done, I've actually started up, and actually let me just quit it so you can see. So I installed a while back this thing called, I use an open source Smalltalk called Pharo, and Pharo has a launcher, which what I've done is for quite a while, I was actually using Pharo 8.0, but can you see my screen still, Sarisha? Or?
Yes.
Okay, cool.
Yeah, it's a bit small. I don't know if you can actually increase.
Yeah, it'll be better when I don't know if I can increase the size here.
Okay, that's fine.
Bigger. It'll be bigger once I start the IDE. So what I can do is I'm just going to click launch here. And what you can do is actually you can create new images and have multiple versions of Pharo running. So I have both, 8.0 and 10.0 still available. So if I click launch here, it's actually going to start my Pharo ID. Is this more visible or?
Yeah, that's better.
Okay. It's interesting because I set the fonts to medium for the talk today. You'll see when I do some stuff, the fonts rendering and like different dialog boxes gets a little bit, mushed together. So, but we'll deal with it. So one interesting thing, I guess, to learn about Smalltalk is that when you start up a Smalltalk, what they call image, you're running kind of like within a Smalltalk virtual machine, but there's an image that actually has persisted, kind of the running state of the system. And this was basically everything that I had previously open on my image opened up at the same time. You can say like it's somewhat different than just opening up tabs in an ID like IntelliJ because it could actually remember the current state. I could have actually had a running program here with a debugger and actually shut down and saved my image. And if I restarted it, then it would actually start back exactly where I was with the entire state, available. So looking at like what I have here is what's called the playground. And if you click anywhere in the Pharo kind of a canvas, you'll basically see different options, and you can just open up anywhere what's called the playground. And in the playground, it's just a useful place, and structure that they've created so that you can, execute snippets of code. Back in the day when I used Smalltalk professionally, like over 22 years ago, and the Smalltalk I used, there was a concept they called workspaces, where workspaces, similarly, you could type code anywhere and just execute it. And then, you have a specific output. This is called the transcript. So let's say I want to do the simplest thing. I actually want to print hello world. What I can do is call transcript, pass the, send the message show to transcript and pass the parameter hello world. And there's a special syntax in Smalltalk for cascading messages. So what I'm going to do is send the message CR also to transcript. So if I execute this, I just swipe the code and say do it, you'll see there's hello world, right? Now, what's interesting is Smalltalk, when you're running in a Smalltalk IDE in a live image, you're actually in a Smalltalk program itself running, and you can completely, introspect and look at everything in the environment. So you saw I just did transcript show hello world. What I can actually do is if I right click on transcript, I can inspect it. And now I'm actually looking at the instance of transcript that's currently in the image running, which is actually being displayed over here. And what you can see is like, this actually came up before, it's showing a little demo. It'll typically like come up here when the inspector comes up, and then, when you see self here, I can type code anywhere, or anywhere that I can type code in Pharo, I can basically, get that code to execute as long as I can swipe it. So I could put hello world here. I'm now sending the message show to self, which self is the instance of this object that I'm looking at, the inspector. So if I execute that, you'll see, hey, there's hello world again, right? And so on and so forth. So that's a little bit. Anywhere, once again, I can highlight code. If I right click, I can inspect it. This one's always fun. It's something that you wouldn't expect, and capability to find in a language like Java, right? If I say 10 factorial, this will actually calculate factorial, and you can see like I get back this value in integer. It's actually a small integer, just 3628800. And what's interesting is you saw it was like small integer, right? Was that actually, let me leave that up. So 10 factorial comes back with small integer. And if I do 100 factorial, which will be a much bigger number, you'll see now it comes back, well, it's a very large number, right? A large positive integer. So the type is actually different, right? And this is where like the dynamic, typing aspect of Smalltalk is quite useful, right? Because the trouble with like defining something like factorial in, a language like Java is like, one choice is like, well, do we use primitives? Well, if you use a primitive type, right, I can only support a very small factorial option if I keep it at int. I can maybe get a lot larger if I go with long, but at some stage you may have to go with something like a big integer, right? But you can't switch from like a primitive to a, object. You've got to make a choice there, right? Whereas Smalltalk being dynamically typed, it, dynamically figures out what type to return based on, the size that needs to come back. One of the most surprising things that I first learned in Smalltalk, and it made perfect sense to me when I learned Smalltalk, and then it hurt my brain when I learned Java. What do you think this returns if I say 1 divided by 3? What would it return in Java? It returns 0, right? So interesting thing is if I do 1 divided by 3 in Smalltalk, and this was again very surprising the first time I ever did it, if we look at it, it comes back with a fraction. And you're like surprised at first, like, oh wow, a fraction. what language, never seen a language do that before. But it makes sense, right? 1 divided by 3 is 1/3, right? Of course, why not come back with a fraction, right? And the idea of actually having fractions and being able to, return that as a type and use fractions to really do arithmetic where you don't have to worry about like, losing precision, right? When you have things like 1/3 or, some other thing which would result in, a long, never-ending repeating decimal, right? So that's interesting. What I'm gonna do is, if I highlight this, right, and this is the interesting thing to understand as well with Smalltalk. Smalltalk has, it turns out it's 6. I thought there were only 5 reserved words. I forgot one. So these are the reserved words in Smalltalk. There's nil, true, false, self, super, and then this special variable, this context. And that's pretty much it. Everything else is fair game in the language. But what was also interesting with Smalltalk, everything is an object. So you can see, like, when I look at nil, nil is an object. So if I look at it, nil is an instance of undefined object, right? So, that's kind of interesting. And if I, there's something, if I can recall how to do it, there's some meta kind of like definition of object itself. I believe, let's see, if we look at the object class, and I'm gonna, starting to learn shortcuts in Pharo, which is nice. If I do Command B, it should browse the class. Interesting. It used to be like in Smalltalk before, and I guess they changed this somewhat. And so I don't know all the details. Smalltalk, when I worked in Visual Edge, I believe it used to extend, it used to subclass nil. So this is actually the class definition for object in Pharo. And it's extending this type proto object, which we could go look at and browse. Oh, that's interesting. Proto object is a subclass of proto object, right? So now you've gone self-referential here, right? And look at that, proto object superclass is nil, right? So nil is an instance of undefined object. Undefined object is a subclass of object. There's some weird magic of like, turtles all the way down going on in the definition. So always a little bit mind-numbing to me, but like super cool. It gives you like this consistency when dealing with things. But so that was a long treatise to basically explain this, where there are no loops in Smalltalk. There's no if statements. Everything is done by sending messages to objects. So if I wanted to have a loop, what I would do is actually write code like this, 1 to 5 do. But this is actually sending the message to do to 1, the small integer. Now, if I just stop at 1 to 5 and I look at what that actually returns and I expect it, this will return an interval. And you'll see like 1 to 5 actually has the values 1 to 5, right? And this is actually one of the places where, once again, I was familiar with intervals from Smalltalk, and we have an interval type. We actually have interval, we have int interval and long interval in Eclipse Collections, and really it's inspired from intervals in Smalltalk. And then what it means is, like, if I want to iterate over this interval, so I can now then do, let's say, 1 to 5 do, I will then pass in a lambda, right? So some bit of code that I want to execute. So if I highlight this code and execute it, you can see it iterates 1 to 5, prints each one to the transcript. Now this one's I thought was kind of interesting, right? Here's an interval from 0 to 1, and I'm going to have this step by function of basically 1/10. And once again, this is one of those surprising things you'll see in Smalltalk, like, oh, that's interesting. Of course, that makes sense. So if I execute this code, so I'm going to go from 0 to 1 by 1/10, right? And then output each, right? And you'll see we start from 0. So intervals are inclusive. 0 and 1 are included. But in between, I get 1/10, and then I get 1/5. So what automatically happened is it's not going to give you 2/10. It automatically reduces fractions, right? So you can see like all the fraction reductions that are actually happening here. So I get like, 1/5 instead of 2/10, right? 2/5 instead of 4/10, right? 3/5 instead of 6/10. So it's interesting, is like, but you can see like there's the order in which it goes. And I could similarly, like, you can have intervals, I believe, over any type of magnitude, which can be numbers. I believe we could do dates as well. So interval is, very flexible in terms of what I could do. I could, let's say, iterate by decimals. But here, to understand, is like, I'm not writing a loop, right? But this is how I would implement a loop. And similarly, like, there are no if statements in Smalltalk. The way I would get things done with an if statement is I would send the message if true to a Boolean, right? And then I could type. Single quotes. That's where I got to get used to. I'll do the carriage return. So if true, it's going to print this, right? Hey, yes. Now I want it to do if false, right? I say if false. Now if I execute this, right? True isn't false, right? So I'd expect it to do nothing, right? It does nothing. But the idea here is like, there's a Boolean class. There are two subclasses of Boolean. If I look at true, because it's an object, right? I inspect it. It's an instance of the class true. The class true, let's see, how can I, okay, I can browse. So you see true is true and false are both subclasses of Boolean. And they define all of these methods. You can see they define if true. They return if true, if false. If false, you can reverse it if you want, if that's more natural to you. If false, if true, right? So you don't have to like just not things. You can actually test for the negative. And then you can see like I can, combine Boolean objects, the not, the or. So even those are not, and you can see like operators here. I can do an ampersand, but that itself is a message to an object. There is no operator per se, right? So that's a little bit about that. I thought this was interesting because like this idea of like objects and messages, and this was surprising to me when I tried it. And then I thought like, oh, okay, well, actually that makes sense. This is how you define a literal array in Smalltalk. So if I inspect this, you'll see like I have an array of 1, 2, 3, right? And you can see this is an array of 4, 5, 6, right? What I can do is actually send the message divide to the array 1, 2, 3 and pass the other array 4, 5, 6. And what do you think this is going to do? So if we inspect it, you'll see I get back an array of 1/4, 2/5, and 1/2, right? So it's actually done the division, but in this case, division of two integers in Smalltalk will return a fraction. So now I've created an array of fractions, and you can see like the last element actually reduced because 3/6 is 1/2, right? And then you can see like other operators as well are just defined as messages. So I could actually do, array multiplication here, right? So I can inspect that and you can see like, now I get 4, 10, and 18, right? If I do plus, they would be added together. This one's interesting. At creates an array of points. So if I look at each one of these, you'll see this is a point with an X and a Y, right? So I can, I was trying these things this week. I was like, oh, I wasn't expecting that. That's kind of neat, right? Now there's a, special, and each one of these is actually a message. It's called a binary message. You can see like it's binary because there's the receiver on the left and then a single argument on the right. But if I highlight this one where I, have the comma between the two arrays, this will actually concatenate the two. So now I get 1, 2, 3, 4, 5, 6, right? So I thought those are kind of neat. You've already seen, I guess, like those. There are literals, like this is how you represent, why this isn't scrolling. I think it's like competing. Uh-oh. Okay, I think Zoom is having fun. My environment, hopefully it's not gonna crash on me or something. So I can look at a string and inspect it and you can see like, there's a string, right? And what I could do here is just say, if I want the string to uppercase, right? Just say as uppercase. Highlight that and inspect it. Now I've got an uppercase string, right? So on and so forth. And string, as I mentioned before, in Smalltalk, string is a collection, right? So if I look at the string class, what if I can Command B directly on it? Oh yeah, it did, good. So you can see string actually is a subclass of arrayed collection. So it's got all of the collection protocols, and they're voluminous, right? So anything I can do with a collection, I should be able to. Yeah, you can see like these are all the parents, right? So if I look at all the way up to collection, right? Quite a large number of methods. You'll see things like collect into a lot of collection APIs that just work with strings, right? So I would expect to basically, it's a good example. I could say string select, and this is gonna, let's say, filter. And each here would be some character. And I can say each is uppercase. So I would expect that to come back with a string with just S in it. And there it is, right? So once again, full collection protocols available to, string, because string is just a collection. And this is one of those places where, once again, I was inspired by my Smalltalk background. I wanted the same kind of like string collection behavior in Java. So we have our own types to kind of provide those things. There's in Eclipse Collections, we have a char adapter, a code point adapter, and a code point list, which basically give collection-y type protocols. They're primitive collection protocols for strings. The interesting thing is, like, because there's no primitives, like this is what a character is represented as in Smalltalk. So that's just $, and then some value. So if I inspect that, you'll see that's an instance of character. Oh, it remembers as uppercase. So let me execute that. So if I have a character and I say uppercase, right? You can see now I've got an uppercase character, right? Character R. Yay. So, and this was another surprise I found out last night. In addition to being able to multiply, let's say, divide and add arrays together, if I say array times 2, I figured I'd experiment, and sure enough, it works, right? So I inspect that, right? So it multiplies all the elements in the array, comes back with a new array with all of them times 2. And there's a very interesting and subtle coolness about what this has done, because I've sent the message times with the parameter 2 to this array. And what the array winds up doing, and actually if I highlight this and I say code search and look for implementers, you'll see like I can look at a collection, and you see this in collection, it's defined as times arg, so this is our argument, and it's then going to call arg, so it's calling back on the number 2 in this case, adapt to collection self, right? So it's going to pass itself, and it's going to send this self, I guess in this case is the collection, right? And then it's going to send this $X, and this is a symbol. So if I highlight it, you can see it's a byte symbol, right? So in times, and a byte symbol in Smalltalk is a unique string, and it's actually how you can, very easily do reflective programming in Smalltalk. If I said something like string perform, I'm guessing this is going to work. Let's see, yeah. And then I say pound or hash, whatever you want to. Probably pretty funny. I'm calling it pound. Is uppercase. So this is actually going to send the uppercase message directly, right? And if I inspect that, oops, it would help if I actually put quotes around it, so it's not a string. Uh-oh, maybe I got it wrong. Let me look at the message. Live coding and debugging. Undefined object. Instance of byte string did not understand is, oh, duh.
You didn't need the pound sign.
No, I gave the wrong message. I wanted as uppercase. And I probably, you know what, it might be spelling as well. That could be capital, but let's see. Well, you know what, easier to do it. Let's write exactly as I would without sending it. So as, okay, it's lowercase, so it should work now. Okay, good. So performed the as uppercase method on string. And that's important for you know, what we were just looking at, which I close now. When, you know, we look at, let's say, code search implementers of, and you can see like arg adapt to a collection. And then what we can do is we'll code search on implementers of adapt to collection. Oops, nope. I want this. Why is it not, why am I? I'm like competing with my. Okay, there we go. So in collection, you can see this is the method implementation of adapt to collection, some receiver, right? And you know, then send the selector. And you can see what this is actually doing is it's going to call collect on the collection. I haven't, you know, for those that don't know Smalltalk or Eclipse Collections, you have no idea what collect is. What collect will do on a collection is actually transform one collection to another. So it's going to create a new collection, actually transforming. And in this case, what you can see it's actually doing is it's transforming the collection by taking the receiver, which one is receiver element? So receiver element, so it's receiver with self. So I've got two collections here, right? So it's going to iterate over them together. And you can see like I've got two elements now in this block. So the receiver element is going to perform the selector, which in this case is hashtag times, you know, with the element. So so this is what winds up happening is you create a brand new collection multiplying both elements together in this particular case. Then there's the case of times where the implementer of this, let's see if I can get this search to work again. So the other, that's the collection implementation. If you look at the number implementation of adapt to collection, this covers the case where you're doing, let's say, array times 2. So you can see it's just going to do array collect for each element. It's going to perform the selector with self, which in this case is the number 2, right? So I know it must look really odd, but this is once again one of those cool things of like, you're not dealing with like primitive numbers that have special operations. They're just objects. They just have methods on them and messages you can send them. And what's interesting in Smalltalk, if you send, and you kind of saw it before, I can just type any text. I don't know, uppercase, and when I send this message, and it knows enough that it's not available, but I could still inspect it. And I'm going to get a special error, the does not understand error, right? This is the key thing. It's like, you know, I could save this code and it would compile, but you can then, you know, effectively have this case, and you can actually wind up overriding this message for an object called does not understand and deal with the fact that you're calling a method that doesn't exist, right? It's a very advanced thing you typically do, like, you know, it was one way I remember back in the day implementing proxies that way. You'd have a proxy for some type. You could send it any message and it would route, let's say, the message to the type itself. It didn't have to have in its own implementation. Okay, so that was my quick introduction to some Smalltalk syntax. And
Don,
Smalltalk,
before you move away from this
yep.
page, or from this ID, I guess, there is a question from our participants. CR, what does CR stand for? Or
It
what
stands
does
for
it
carriage
represent?
return.
Okay.
So all I'm doing is, if I don't do that, it's going to basically print wherever the current cursor is in the
Oh,
transcript.
okay.
So
Got
by
it.
doing CR, it's going to guarantee, like if I get rid of that, you're going to see it's going to tack it wherever,
Understood.
right? And CR is, you know, a method that transcript understands. So if we look at transcript, the class, you see CR there. And all it does is there's a character CR, which you can see I can highlight this and inspect it, right? So this is going to be the carriage return line for each character, right? I doubt I could do uppercase on it, but but yeah, so that's all it does. It just puts a carriage return on the receiver in this transcript. So therefore, once again, I'm not going to just stack text all together and have to go and do things like, okay, let me press enter here. I do that in code, right? So that's what CR is.
Okay.
Make sense?
Yep.
And this part here it's kind of unique to Smalltalk. This is what's called a cascaded message send. This is the equivalent of me saying this and then doing that. It's just a shortcut, right? It says, okay, whatever you sent CR to, send show to exactly the same thing. So that's also going to the transcript object. It's a neat shortcut. Okay, so with that, like when I'm coding in Smalltalk, I'm going to jump in now, and there's a few blogs that I mentioned in the slide deck. I guess like I'm going to first show what the Smalltalk Collections API looks like, and there's a blog that you can walk through on your own time if you want. I don't know if Suresh can send the link to that blog in the chat, Exploring Smalltalk Collections. So I'm going to walk through that, and then after that, and I'll show basically the same APIs in Eclipse Collections, so you can see it in Java. And I'm just going to walk through tests with it, right? So I like doing, you know, and this is something I would say in a lot of ways, like I was inspired when I was working in Java because I didn't have this cool feature initially. Later, we got these kind of things with like IntelliJ has the Scratch, where you can actually just take random Java code and execute. And then in Java, when did we get REPL in Java? I forget what version. But you can see like, I've got REPL anywhere in Smalltalk. I just highlight code wherever I want and I can, you know, execute it, right? So I missed that ability to just highlight code and run it. And in Java, what kind of became my replacement for that capability were unit tests. Because in unit tests, I can write some small bit of code and then just execute it, right? So it's easier than just creating mains everywhere and trying to execute code, right? But what I'm going to do is like open up a class browser. So this is how you browse. I'll do system browser. This is how I, you know, create code in Smalltalk. So you can see like this looks at the entire class library in my image, and it's organized by this construct here, which are packages. So I created a package called collection API tests. And you can see I have a single class here. Collection API test is the class. It extends the class test case. It's in this package. You can see I have a bunch of instance methods. And the way, and this is kind of neat with the way Pharo has integrated with the unit testing framework. And the unit testing framework in Smalltalk is really, that's where kind of like the whole XUnit, which we know as JUnit in Java, but any kind of the XUnit stuff, it actually started out in Smalltalk as SUnit. And it was a paper that Kent Beck wrote back in the 90s describing a simple testing framework in Smalltalk. And test cases, you know, one of the, you know, the primary classes that's implemented, you know, and based on, you know, his original work way back in the 90s, right? So what's interesting though, like in the browser, the way they've integrated it, when I look at an individual test method, so I'm going to look at, let's say, test select first, right? So this is the code I have for basically, I'm going to create an ordered collection of fruit. And in Smalltalk, an ordered collection is the equivalent of, let's say, an array list in Java. And what I can do is like quickly create a collection by using this. This is a single method or message I'm sending with 5 parameters. And you can see like this is what's called a keyword message in Smalltalk. So I can say with, and each with actually has its own parameter, right? So if we looked, for instance, and just to prove that, if I do co-search implementers, you can see there's the method with first object, with second object, with third object, right? And all it's doing is self new add. It's using cascaded messages here. So it keeps calling add, sending it to the result of self new, right? And this is a special return type in Smalltalk. Every object knows you can return yourself, right? As a final call. So I create a collection of fruit, then I create a set with banana. So set another, the equivalent of, let's say, hash set in Java. And what I want to do is like take the fruit and filter the fruit based on whether or not that fruit is included in this set, right? So, the way I run stuff, so I can say like, let's say, what's a way I can, if I change this to reject, this will fail. That's one way to get it to fail. I just want to show you the test failing, right? So if I run this now, this should fail. And it didn't fail. Why didn't it fail? Oh, I didn't save it. Yeah, okay, good. Now it fails. So if I change that back to select, so this is doing a filter on a positive condition, right? And once again, if it's including, I'm expecting that the result will be basically an ordered collection. And select, basically a method directly on the collection itself, will return the same type as the collection. So it's going to return an ordered collection. It would help if I saved my code before I run it. So I save a method. And this is the interesting thing to understand about Smalltalk as well. You can see when I'm working in a class, I'm not working in a file. I'm working in a browser that has the class, and I can't see all these methods at once. I can only see them one at a time. So what happens when I save the code for this, it actually is saving it and compiling the code at the, at the same time, right? So as soon as I hit Command S, it's saving it, and then it's available to run. But you can see like this is the method select. It takes a lambda, a predicate to filter, right? The opposite would be reject, right? So if I reject, I'd expect then if it's including banana, I want everything that is not in this set, which would be apple, apricot, blueberry, and clementine, right? And you can see like in this, since I extend test case, I have the assert equals method available, which you'd expect, similar to like what you would see in JUnit with either the assert class if you're using JUnit 4, or if you're using JUnit 5 would be assertions class, right? And then we've got none satisfy, which will return true or false. In addition to assert, there's the deny a message. So you can either assert something or deny it, right? So it's the, the false side. You can see what grouping by looks like in Smalltalk, and the grouping by implementation. And all of this code, by the way, is in that blog link. Did you shared it, or Sarisha, or no?
I did.
Okay, awesome. So you'll see all these examples in there, and there's actually, I have a GitHub gist in there as well. So actually, let me just, I move this. Okay, there we go. So yeah, so if you look in here, there is a GitHub gist, which makes it easy then to see all of the examples and look at the code, right? So this is pretty much what I'm showing you directly in the IDE right now, right? So we'll go back. So yeah, so that's a bit. Now, if you look, the equivalent, let's say, in this case, a grouped by in Smalltalk will actually return, if I have an ordered collection, it's actually going to return an ordered dictionary. Smalltalk doesn't have a multi-map type, right? Which is something that Eclipse Collections does have. And if we look at the equivalent in Eclipse Collections, so I'm going to switch to my Java ID. I'm going to switch. So in the Eclipse Collections Kata repo, there's a test called the top 25 methods test, and there's a whole kata for this, the top methods kata. And in the top 25 methods test, you'll see like, oops. Doesn't like that. Let's see, how can I get structure? There we go. So you'll see I have tests for all these methods, right? So if I want to look at select, right? So this is a select code, similar to like the Smalltalk example. The examples are identical. The implementation is somewhat different. In the Eclipse Collections tests, I implemented fruit as a an enum. So you can see there's apple, apricot, banana, blueberry, and clementine. But the tests themselves are the same. So I actually have a set called only banana, which contains banana, right? And I will filter, the fruit based on, the set containing banana, which then comes back with a single list of. And you can see like the same thing for like reject. Now in Eclipse Collections and with Java, I'm using, instead of lambdas, I'm actually using method references here. So if you're not familiar with method references, it's a neat feature that, there's not an equivalent in Smalltalk that I'm aware of, it's a nice feature in Java that we have available. So I always say like I have a method reference preference. So there's that. And so you can look at like, let's get these different examples that are out here, compare and contrast the syntax. Obviously, like when you're looking at Smalltalk syntax, I don't know if it's jumped out at you, but basically this is assignment in Smalltalk, colon equals, right? You don't have separators, like you don't have dot and then method. It's actually messages are separated by spaces, in which case then parentheses sometimes become important. The end of a statement, it's not a semicolon, it's a period. So almost like it's like an English sentence, right? Keyword messages, once again, have this structure where it's like the method name with a colon and then parameters after each number of parameters that you have. This is actually me creating the target map output. And if we looked at that, right? So you can see this ordered dictionary. What I've done is I've grouped the collection by its first letter. So it's going to be A, B, C. So I've got 2 for A, 2 for B, 1 for C. And if I look at like the key for A, you'll see like there's an ordered collection of apple and apricot. For B, banana and blueberry. C, clementine. Once again, the nice thing is I can, just look at that bit of code. I could also I'm not going to get it right. How do I, I want to try and debug. I haven't tried this in Pharo, so I'm probably going to hurt myself trying it. Where'd the break go? Yeah. Well, it stopped on it, right? Now let's see if we can try and step through a debugger in Smalltalk. So I'm on the statement. I should just be able to go over. Hey, yay. Wonder if I can, I'm not going to be brave enough to go into. Let's go over. And then I should be able to look at group by first letter on the stack. So I should see it here, right? There it is. So group by first letter has the ordered dictionary, right? Which, I open that up? Yeah, there it is. And this matched what the expected output was here, right? Hey, it's the first time in over 22 years that I've done any debugging in Smalltalk. Most of the time, it just can I clear that? Oh, good. Most of the time, I just swipe code and execute it and see what my expected result is to deal with things that way. So that's kind of like a bit of an intro. You can see, like, once again, And the other blog that I had, the Java streams are great. Link, if you can put that one, Sarisha. This actually does a compare and contrast between the collections APIs and Smalltalk. Also compares, I think, to Java. But like one of the interesting things is this mind map that I put together. This actually shows you the entire kind of like collection API in Smalltalk. So these are all the methods that are available. So it's quite a difference between the rich API you have in Smalltalk for collections and the somewhat, anemic API that we have in Java, right? It's like the API was really augmented by having Java streams, right? So that's out there. You can kind of, once again, see some different comparisons. There's obviously like a lot of detail out there to go through. What I want to do is I'm going to jump now into the other set of tests that I have. So I have a test, and there's a blog out there as well. This is the, can I move this? This blog. So the comparing my Smalltalk and Eclipse Collections Wordle Kata solution. So there was actually, there was a YouTube video together, and you can actually find the link in this blog. So if we actually open that up, So this was a video put together by Jose Pumard from the Core JDK team, the developer advocates. And basically, Jose and I did what we call a jet lag driven development challenge, where we tried to, compare and contrast implementations of a Wordle Kata using Eclipse Collections and Java streams. So you can watch this video. You can see it's what, how long is it? I think it's like 37 minutes. It's good fun. But based on like that, what I went and did was I then took the challenge and challenged myself to like, well, can I do this in Smalltalk, right? So I took the Wordle Kata and implemented it in Smalltalk, and then actually, did a step-by-step explanation of how to go implement it. And what I can show you is like the actual code. So if we look at, I have a package called Wordle tests, and in it I have a bunch of tests. I also have this Wordle class, right? So in a Wordle class, if you create it, you'll have a hidden variable. So this is how I define an instance variable for a class in Smalltalk. I have this variable called hidden. I have a setter for hidden so that I construct a Wordle class, set a hidden value. And then what I can do is submit a guess. And actually this code will compare my guess to the hidden implementation and actually output a series of results, basically that will match, telling me whether or not I've got letters correct and if they're correct in the right positions, right? So, and the Wordle Kata itself like explains some of that detail, right? And the code, somewhat similar, and I have basically a similar implementation. It's slightly different though for Eclipse Collections, because this is one of those cases where there are behaviors that I have in Eclipse Collections that are not available in Smalltalk, and there are behaviors in Smalltalk that are not available in Eclipse Collections. So it's an interesting case of like, oh, I get to learn some things here. I wonder, what, if anything, I want to do about it, right? So one of the things that Smalltalk has, and if you look, there's this guess implementation here. And the way it works is basically, if I take a guess, this is going to be some string. What I'm going to do is I had some hidden variable. And let's say in the case of a test, and I have some test data. So this is going to be the hidden variable. This will be the guess, right? And this will be the output that I expect based on that guess, right? So in this case, like there are no matches, right? So I expect to see all dots appear, right? And then I'm trying to remember like which is correct in the position versus not. So I guess like we can probably look at it by the data. Okay, so this suggests that I have a letter, but it's in the wrong position. Or if it's uppercase, it's the right letter in the right position, right? And what you can see here is like what I've done is, and this was actually different than what I originally did in the blog. When I first wrote the blog, I hand coded all of these asserts creating Wordle, new, passing in, there's my hidden variable. There's a cascaded message that I'm calling guess, which will be on the instance of Wordle. And then I'm validating that hidden with this guess, hidden AAA with guess of BBBB equals, all dots, right? All periods. So after I wrote all this out, and then I had to do exactly the same thing on the second method that I wrote, the implementation that I provided, I said, well, I don't want to have to write that data twice. So let me go and factor it so that I can put the data in one place. What I decided was like, this actually creates it's a two-dimensional array. Interestingly, and this was a neat discovery, right? Smalltalk has the ability to just format code. So I had everything typed out and it was all vertical. And when it did format code, it actually stacked it together like this, which is like, this is first, second, third, fourth. It's just left to right. Somehow its formatting rules work this way, and it's somewhat pleasing. For whatever reason, it's like, there's good symmetry. So I liked it. So what I decided then as well is like, I don't have to write out all those individual certs. I can then just loop over the data. So here I'm over, let's say, looping over the hidden expected data. And for each element there, you can see I've got a 3-element array. Interesting thing with Smalltalk, Smalltalk is not zero-based indexing. It uses one-based indexing. That'll hurt your brain in either direction that you're going. If you're going from a zero-based indexing language, that'll hurt your brain. If you were like me and coming from a one-based indexing language going to zero-based, that'll hurt your brain too, right? I've somehow gotten used to it now. But so each at one, this is actually the first position. So I would say it's more natural to human thinking. I would say zero-based has some nice properties with regards to, let's say, dealing with computer languages. But so I create a new Wordle. I set the hidden at whatever the current row that I'm looking at 1, set the guess to 2 and set the equals to 3, right? And then I should be able to run this test. And you can just click on this and you can see this runs the test. If I click on this sphere, runs that individual test. If I click on this sphere, it runs both of them, right? And what you'll see is going back to guess itself, what I do is I take the parameter guess, I'm going to compare with hidden, but the first thing I do is create a bag. So bag is an unordered collection, and we have a bag type in Eclipse Collections. This is one of those things that inspired from Smalltalk. Java doesn't have a bag type. A bag type is an unordered collection that allows duplicates, and really like implementation-wise, what it does is it's a collection that keeps track of counts of things. So it's really useful if you had, let's say, a map of k to some integer type, whether integer or long, right? So I'm going to create, this bag, and then there's this method on. So if I look at like implementer, so there's actually a single method here. It's called with do. That's not what I want to look at. Code search implementers. Okay, so you see with do, right? And what with do does, and this is not a method we have on our string-related types in Eclipse Collections, but it's a method on sequenceable collection in Smalltalk. And what it does is allows you to iterate over 2 sequenceable collections in tandem, same time, right? So you don't have to deal with like index lookups into one or other. You have both elements in each collection, as long as they're the same size, right? And you can see like, they give this example 1, 2, 3 with 4, 5, 6, and then do. And what you got is a 2-argument block, where this is the element of the first collection, this is the element of the second, right? So using that, I use with do. So now I've got basically, because I've got 2 strings and they're both collections, I'm going to look at the first character of hidden and the first character of guess. And what I'm going to do is see, are they equal? So this is how you test equality in Smalltalk. It's not the equals method. It's colon equals for assignment. Equals is a message that you actually send to an object. So this is how you implement equals in Smalltalk. And I say like, if they're not equal, so if false, right? I want to add the hidden character to the remaining. So basically what it's suggesting is like, if I don't have a match, keep this in this remaining bag. I haven't done a match, but I want to actually remove anything that I've actually matched, right? Then I'm going to actually, there's another method, which also takes the 2 collections. So there's the hidden string, and I want to say with the guess string, then collect. So this was do. So do is just going to perform something. There's no return type for do. It's, going to actually wind up adding and mutating, adding into this bag. Whereas collect, what collect is going to do is it's going to say, take these two, collections, in this case, these two strings, and then come up with another string based on that. And, collect takes a lambda, some function type, right, which will return something. And what I want to do is, like, I have the hidden character, the guess character. I want to say if they're equal, so they're in the same position, I want to convert it to uppercase. So I convert the hidden character to uppercase, right? If they're not equal, and I want to, call remove from remaining, and if it's absent, so there's this remove if absent code, I want the result to basically be a period. So this is where I don't have a match. If absent is false, right, so it's actually in there, what remove if absent winds up doing is actually returning the value that you're removing. So this is actually going to have already the lowercase value, which will say, like, I have a match, but it's in the wrong position, right? So that's the implementation there. I provide then a second implementation using this other method. Instead of using with do and with collect, I use with index select. And this is a case where in the, so again, Eclipse Collections doesn't have an equivalent of with do for strings. As it turns out, we do have a method on list iterable. Bear with me because my Control F12 is not working with Zoom. It's getting confused. Oh, it worked. Good. We do have for each and both. This is the equivalent of with do, but this only works with object collections. I don't have it working with, let's say, code point adapter or char adapter. So there is no for each and both. We could add it. It's one of those cases where, like, do I want it? Do I not want it? Is it useful? It'd be useful for a Wordle Kata. So I'm not sure if I'm going to go at it. But if we go back, Smalltalk has this with index select. But if I look at this, right, and actually let me start typing it so you can see when I start. Smalltalk does have code assist. Back in the day when I learned Smalltalk, it didn't have it. So you can see there's with index do, with index collect, and then with index select. And then there's a with index select select. I'm not exactly sure what that does, right? But with index select basically says filter. Now, when I'm filtering here, I'm actually using this scenario where basically I have to say not equals. So actually I have to negate here, right? Where I say, like, and I'm now doing a lookup in the guess. Whereas when I had with do, I had both characters. Here I have one character, H, and I have the index. So I have to look up in the other string the value at the index. Now I get this is actually going to give me the other character and guess. But I want to do the test of, like, select where they're not equal. Now, technically what this should have been is this should have rejected, right? But as it turns out, there is no with index reject. Whereas in Eclipse Collections, and actually let me switch to the, in Eclipse Collections, this is actually in the Eclipse Collections code base. We actually have the Wordle test in the Eclipse Collections code base itself. It actually winds up being a series of integration tests that we have. You can see here, instead of, like, doing a two-dimensional array, I'm creating an immutable list of triples, right? So I create the 3 strings with the hidden guess and then the expected output. I'm testing 4 different implementations of the Wordle checker. So I have one that uses inject into with index. I have one with reject with index. And this is as close as I could get with Smalltalk, where this is the equivalent of with index select. It's using reject. And we have both select with index and reject with index in Eclipse Collections. So this is nice. So I can test in the negative, which winds up being useful in the Wordle Kata case. Now, what I have to do in Smalltalk, when I select in Smalltalk, you'll see I filter. Now this is going to return actually another string. What I want to do is actually convert this to a bag, right? Because I want to use the remove if absent, capability A bag is, well, then, it's not really important for, I guess, the strings are really small. They're at most 5 characters, but it would be a faster lookup, right, in a bag, as opposed to like trying to, well, actually I couldn't do remove with index anyways in a string because it's immutable, right? So that would actually fail. So I need it to be a bag. But you see, I have to convert it to a bag here. In the Eclipse Collections case with reject with index, I actually, reject with index actually takes a second parameter, or there's a version of it, I think. Let's see. If I do Control P, yeah, there's one version of reject with index which will return the same type, right? And then there's one that actually takes a target type, which in this case is going to be a char bag. So I want to actually create a mutable char bag. And you can see like we have this full complement of primitive collections in Eclipse Collections. So I have that ability to deal with characters as primitives, not having to box them or anything. But then I do reject with index here, and then I do collect with index, right? And the necessary logic to make all this work. And then, you can see here I have to actually convert it back to a string. In the Smalltalk case, I'm still using with collect. I could have, I guess, I could have used with index collect here, right? I think, yeah, I could still do that. It's just, I felt like it was painful enough. Like, let me just use the with index select. And I really like the with collect implementation. This is nice and really simple. I don't deal with indexes. I've got the 2 characters, and I can return automatically the string out of it. So, so that's that. I've oh, look at that. I did more than a little bit in an hour. I think that's
Yeah,
probably a good stopping point for me to stop talking. And hopefully I've demoed a whole bunch of stuff. I hope folks got a sense of some of the interesting maybe things in Smalltalk, what it looks like to actually do some live coding in Smalltalk, right? We could try and implement a method if folks want to bear with me, but happy to take some questions. I see there's like a whole bunch of chat things, so I haven't looked yet.
that's fine. I'm keeping an eye out on the chat. First of all, that was fun actually seeing how you can do this in Smalltalk and Java, which is Eclipse Collections. So that was really cool. Does anyone have any question for Don? You can either use the chat or you can just come off mute and ask your questions. For most people, it must have been a crash course. Like for me, it was for me, it was a crash course. Yeah, for Smalltalk, yeah.
Well, I thought too, well, hopefully it was useful. Like, once again, I don't know that there's many options to go. You can probably go find some YouTube videos if you go searching, right? People demonstrating Smalltalk. I found it interesting myself. It's actually easy enough to power up an environment. It's hard to get started in any language. I would say, I don't know if it's coming across, but one of the benefits you get with Smalltalk is like, you don't struggle as much with the environmental setup. Once you've got the tool installed, you've got an IDE. You can't actually code Smalltalk without an IDE. There's no files. You have to have an image. You have to have an IDE. That's one of the nice things. And like, you can very quickly just start to learn stuff by just typing in code and doing it. So you're not going to struggle with like, okay, how do I set up my project structure? Where do I organize my files? You work in an image. Once you start to understand, like, I create packages, I create classes, I start writing code. Once you get over that hump, it's like, you're not going to set up Maven. You're not going to set up Gradle, figure out like, do I have to follow a convention for how my code? The conventions are pretty simple. It's like, you have packages, you have classes, you have code. You'd have to learn how SUnit works. There's some, learning how to save code, dealing with, once again, you're not dealing with files anymore. You've got live active objects in an image, but it winds up being something I think you can get started very quickly with it, right? And you have, it's funny because like, with the huge open source movement, right? It's been great to see like, hey, we can go out and look at source code on the internet now, right? The funny thing in Smalltalk, when I learned it, like it was, commercial environment I was working in. So it wasn't open source at all from the free perspective. It was expensive. But what's cool is like the entire Smalltalk environment was open in itself. So I can actually inspect and look at everything. Yeah. So all the code was there. And I can not only inspect it and understand it, I can go change it. right? I can actually rewrite methods. I can, let's say, rename. This is where some of the power can get yourself in trouble, right? So I could, let's say, rename new to be Don's new, and like it's super powerful, and that's how I want to write my code, right? But once again, it's like you got this lowering of the curve, if you will, to get started, right?
Right.
Yeah.
So
Don, there is a question for you in the
Okay.
chat. It says, so this is from Philip. On an earlier slide, there was some mention of an analog of Smalltalk protocols to Java lazy API or something along those lines. Did you mention something like that in your slides?
Or was it the Eclipse Collection slide, maybe?
it might have been this one. So Smalltalk, as far as I know, let me, I'll share my screen
Was it
again.
your Eclipse Collections equal to Smalltalk?
What I said
Java?
is that basically Java influenced Eclipse Collections with a lazy API. Smalltalk doesn't have a lazy API that I'm aware of. So pretty much like all of the behaviors I was executing on collections of Smalltalk, they're methods directly on the collections, and they're eager. They execute right away. There probably are lazy libraries maybe available for Smalltalk. I'm just not aware of them. It's not a feature built into the framework. And it's interesting because like in that regard, I would say, and that's why I say like on the Smalltalk side, right? Smalltalk influenced the eager nature of Eclipse Collections. So Eclipse Collections has both eager and lazy APIs, right? It's like, so once again, this idea of like, why not both, right? They're both useful. Why would you want one or the other, right? You know, so bringing both those together, like we have both, yeah, lazy and eager APIs available in Eclipse Collections. But yeah, Smalltalk itself, you could implement. It's funny because every once in a while I say to myself, hey, maybe I'll go implement some lazy collections in Smalltalk or some lazy iterables, but I have yet to do it. You know, I'm guessing it probably wouldn't be too hard. Pretty much I'd have to define similar to like what we have in Eclipse Collections today in terms of lazy iterables. It probably would be useful, but Smalltalk went a different path, and this was something we did early on in Eclipse Collections as well. Where's my, there it is. So on, let's say I go look at, because they don't have a lazy API, there was, let me browse it. I'm sharing, right?
Yeah, we can see.
Okay, so, and folks that are, you know, familiar, or if you go look at Eclipse Collections, you'll see things like this. So because there's no lazy API, when you've got methods that say, let's say I wanted to basically do a filter and then a transform, so a select followed by a collect. In Smalltalk, you know, if I call select, it's eager, and if I call collect, it's eager, so I'll have to wind up creating temporary collections. In Java, you would do, let's say, a filter followed by a map, and then you'd have some terminal operation, right, that you would call. So you'd have one pipeline that you execute once. You're not going to iterate twice. The way Smalltalk got around that is like by implementing these fused methods. You can see like select then collect, right? Well, it's interesting because this actually, it doesn't do what I was actually expected to do. This actually is going to wind up, this fuses the two calls together, but it's actually going to wind up creating two temporary collections, right? In Eclipse Collections, we actually optimize that and say like, if you've got a fused operation, we want to actually do the compound operation together. It's not really pipelining, but it's going to write, let's say, the loop with the if statement to do the filter and then the transform inside of the if statement. So, but yeah, so this made it easier to write the code. It's actually going to not make it more, any more performant, right? It's purely utility, as you can see here, to improve readability. It's not going to improve performance at all, right? Whereas in Eclipse Collections, when you look at, let's see, we can look at rich iterable. And we do the equivalent of select followed by collect is collect if. So if we look at collect if, you can see it takes a predicate and a function. And our implementation a whole bunch of them. I'm going to probably step in several times before we finally get to the, yeah, okay, there it is. There's the loop. So collect if is eager. You see, we're going to loop over the collection. We get some element out of the collection. We check some condition against it. So there's the filter. And if that condition is true, we're actually going to add the result of applying the function to the element so it gets added to the target collection, right?
Yeah.
So this is combining select and collect together, which is different than saying I do select and then I do collect, or doing a pipeline of operations, let's say in a stream, right? It's literally like spelling out. That makes it very easy to debug this, right? Because I can just stick a breakpoint here and step through it, right? You know, notoriously, it's much harder to, let's say, debug, you know, I would say a stream code where you've got like, you know, filter followed by map and then to-list operation. Trying to debug that can drive you a little bit batty.
Yeah.
So.
Don, I don't see any more questions on the chat, but we have to thank you first, like before we forget and we leave, all of us leave. Thank you so much for joining us at Pittsburgh Jug. This was a very interesting session, very different from what we normally do. So
Yeah, it was a lot of fun.
Yeah, that was a lot of fun.
Last thing I would say to folks is, you know, I encourage folks to learn lots of programming languages, but don't limit yourself to just the new and shiny, right? There's a lot that still can be learned from, you know, some classic older languages like Smalltalk and Lisp, right? But yeah, hopefully folks enjoy it, and you know, hopefully when the recording goes up, you know, folks can enjoy it.
Yeah, we'll have it
after effect as well. So, but
up
thank
in
you
the
both
next.
for inviting me and for allowing me to do this. This was a lot of fun. So.
Yeah, we actually have one last question for you. It should be pretty quick.
Okay.
So what Smalltalk did you use back in the day?
I used IBM's Visual Age for Smalltalk, which, you know, through, you know, some history, if you're curious, like IBM Visual Age for Smalltalk was used to implement IBM's Visual Age for Java, which later then became Eclipse, right? And Visual Age for Java was implemented in Visual Age for Smalltalk. They later, when they implemented Eclipse and open sourced it, they rewrote it all in Java. But yeah, so I first learned Java in a, you know, similar IDE that I was used to in Smalltalk, which was like image-based and like dynamic. It was a really nice way to learn Java. And then it got all taken away and we went with files. So, but thank you for the question.
Mm-hmm.
When did lazy collections? I guess show up where? In Eclipse Collections, we started out eager, added fused, and actually I have a blog on that somewhere. But probably, I don't know, it's probably like 15 years ago with Eclipse Collections, we implemented lazy iterables. So it's been quite a while. And there's actually, I think there's a slide deck I have somewhere as well that actually shows the progression of different features as they were added to Eclipse Collections over the last 18 years. I forget whether we had lazy first or immutable first, but at some point we started mutable, we then got immutable later, we then had lazy, then we had parallel, which parallel actually started out very early on. We had parallel utility that was eager. I have no equivalent out there to our parallel eager utilities, and I have a whole blog on that. But the parallel lazy, so we did a lazy, you know, parallel API that's purely lazy on Eclipse Collections as well. So yeah, I would say like, I don't know, it's going on like 10, 15 years. I forget the exact dates of when we do stuff. It's been so long now.
All right.
I come from Park Place Digitalk background, so.
Oh, really?
Nosy about other small talks. But it's 25
old,
years gone by.
Yeah, good old VisualWorks.
Yeah.
It's funny because like I know like, well, Syncom still makes VisualWorks, right? They're still making what's the other one they have?
Digitalk Smalltalk was
no, there's I want to say it was like, what was the ancestor of Enfin? There was some Object Studio, I can't remember. There's two Smalltalks I think that they still market, but VisualWorks I would say is probably the most well-known one, right?
ObjectWorks and VisualWorks. That was
there was another one, I guess, like it was, I thought it started out as Enfin, and you know, they renamed it at some stage if I'm not mistaken, but I'd have to Google.
Arts for Smalltalk. I don't know if that.
Well, you know, let me let's do
If only
this.
there
We
was
can-
some search engine that would
There's
tell
some
us these
search
things when we
engine.
get it.
Google,
Should be in my memory.
Syncom.
Sorry, I'm going into Smalltalk
The
history.
products
I
they
should-
have, oh, it's called Object Studio now. They have Object Studio and VisualWorks.
Object Studio. It was Object Works. I guess they restored.
Yeah, I don't know if
Yeah,
it has,
they all went visual. It's like the same year. Object Works went to VisualWorks. IBM came out with Visual Age. Digitalk became Visual something. I don't know.
yeah, and it's funny because like I miss my Visual Age environment so dearly because like, and I guess like it was I'm not sure it was like from parts, Digitalk parts that they got the inspiration, but like the visual connection metaphor was like so powerful to demo, right? And it was amazing how quickly you could just build, like that was like in the heyday of my UI building. It's in Visual Age. It's painful for me now, like, you know, and having gone from, I've done Smalltalk, I've done Visual Basic. That's a step in the wrong direction. And so in some ways that probably made my, what was that?
I'm not going to disagree.
Yeah. So, but moving, you know, then from, you know, let's say a 6-month contract doing Visual Basic to Java, that was at least a step forward in, you know, a better direction. But, you know, I think, you know, again, having learned so much, you know, from the 90s, I still try and, you know, I love trying to keep my mind fresh in terms of understanding the history of where things came from and, you know, how they were impacted. There's still some folks obviously roaming around. You get the, you know, more famous folks like Kent Beck or Martin Fowler, who are, you know, both had Smalltalk roots. I think, you know, it's nice to see some, you know, folks active in Twitter and stuff. So, yeah.
Yep. Well, it is 7:30. So I think we're gonna stop it here, but it's been a lot of fun and we're definitely gonna get this video up in the next 3 to 5 days, maybe sooner.
Yeah.
But
Thank you.
Yeah.
thank you, Don.
Thank you, everyone. Yeah.
Thank you.
Bye-bye.
Yep. Bye.
Bye.
Bye.